Hello guys, how are you? So today is the day 4 or we can say a last day of deep learning. Today we will bind up the session of deep learning and then continue the NLP in the next section or we can say a next lecture. So let's continue our discussion on deep learning. So we have covered all of these like activation optimizers. There are many types of activation function like sigmoid, softmax, relu, leaky relu, and the other one is swish, I think. And these are some activation functions that we have to learn. And most of the time, we will use Adam optimize, not Adam optimizer. Basically, relu activation function. In optimizers, we have many types of optimizers like gradient descent, stochastic gradient descent, mini batch SGD, and we can say SGD with momentum, AdaGrad, RMS props, and the best is Adam optimizer. Basically, Adam optimizer most of the time, like 99%, we will use Adam optimizer. And we have also a loss function we have learned like RMSE, uh, MSE, and MAE or binary cross entropy and categorical cross entropy, sparse categorical cross entropy. We have done all of this discussion. So now today is the last day of deep learning and today we will cover like CNN part basically inside the deep learning. So like CNN, convolution neural network. Deep learning is famous for CNN also. Like you can solve any problem related to CNN like images or videos if you want to solve. CNN is the best thing if you want to solve a use cases related to CNN. In CNN you can solve there are different types of basically problems are there in CNN. You can solve it any problem related to deep learning. So suppose in your head basically there's some cerebral cortex, optical covert. These are some things we don't know, but these are wait 1 minute, my phone is coming. Hello. Yes sir. Mm-hmm. हाँ 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 बोल सुन रहा हूँ। हाँ हाँ तो अच्छा 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 मतलब ये नया वेरिएबल क्रिएट कर सकते हैं उसमें बता सकते हैं। हाँ 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 ठीक है ठीक है। हाँ मतलब जो अपन 3 सजेशन ले रहे हैं ना वो जो पहला तो वो दिखाएंगे और दो जो सजेशन बचे उनका उनका नाम दिखा देंगे सर। ठीक है ठीक है। हाँ 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 ठीक है ठीक है। हाँ हाँ ठीक है। हाँ हाँ हाँ। अभी तो नहीं, अभी मैं रूम पे आ गया और वो नेट सही नहीं चलता है इधर पे। हाँ हाँ ठीक है ठीक है ठीक है। Okay, so let's continue our discussion. So basically we are seeing like this CNN architecture. So basically our mind is basically created of some neurons. We know that. Sorry for the discussion. So our mind is basically created of many neurons. So the scientist came the same solution like what if we create a same solution in our mind, mimic the mind in the new like in our basically in books, or we can say in machine learning, so that we can able to predict it. So basically now start. Sorry for this disturbance. So we are basically I am saying that ki we scientists have see that like what if we create a machine learning model that can mimic the human brains, so that can memorize all of these things. So that's the idea of deep learning basically in behind of the deep learning. These also like we have seen the neurons inside a deep learning model, so these are connected to each other like a neurons in our head. Basically this like visual cortex is there, all of these things in our head is there. So these are the idea of like mimicking the human brains in the deep learning basically. So we have learned the ANN, CNN. In ANN, basically we have like NLP related task, or we can solve also a CNN. Basically, this is basically a structure ANN, artificial neural network. Like if you want to use a classification or regression problem, then we have to use it, input feature or output data. But inside CNN, basically we have only if you want to use images or video related tasks, then we have to use a CNN like image classification, object detection, segmentation. You have seen a YOLO. This is basically a CNN problem, CNN algorithm. So you can also solve a problem related to NLP in CNN, but the accuracy you will not get a good. So that's why we have to not use this CNN like inside a CNN. We do not use a NLP related task. You can solve it, but you will not get a good accuracy. Cerebral cortex and visual cortex we have already learned like the human eyes can read RGB values. So you have seen any color in the world, these are all of these are basically a combination of RGB values basically. Mhm. So if you want to create any problems, or if you want to see any picture in the real world, this is a combination of three colors basically: primary visual cortex, orientation of edge and lines, diff difference in color, complex pattern, object detection, orientation, object recognition, visualization the image. Like any problems related to image, these are comes inside a CNN. Or CNN is basically mimicking the human brains, which is in the visual cortex basically. So we have learned this the image like looks like in our plane to see this image, and like this is a for basically image is basically we can say 250 by 255 by 255. Like image can be of any dimension like if you want, then the value will be ranges from 0 to 255. 0 means a black and 255 means a white color, and the combination of this color basically will made RGB values. Basically RGB values will be basically in this range. And we have learned 0 is basically for black and 225 basically for white images, white color. And by using this combination you can get RGB values, and this are you already I think you know that convolution operation in CNN. Okay, suppose you have an image of 6 by 6 by 1. Basically it's uh, basically a white black and white image because it's into a 1. If you multiply with 3, then it's a RGB image, we can say that. So now how normalize divide by 255. So basically If you do a normalization of this value, then you will get a good accuracy. We have already seen that in our previous lectures, like in NLP, or if you are using a regression logistic, any problem, because there may be some difference in dimensions of like of value ranges from, suppose your number of features is there, suppose you are predicting a house price prediction, then this is your number of rooms, and the second column will contain a value related to salary of a person, then this will be a very huge difference. So that's why we have to normalize so that they will come in the same scale. That's why, so we have to normalize to get a good accuracy. So that's why we have to divide it by highest value so that we can get a the value ranges from 0 to 1. And then now coming to the filter size. What is filter? So basically, if you have an image, then firstly we have to apply some algorithm, or we can say a filter size, and then you will get some output. If you have a 6 by 6 cross matrix, or we say image, then you will get a 4 by 4. If you apply a 3 by 3 3 cross 3 a filter size. So the formula to calculate the output matrix is basically n minus f plus 1 by stride, basically. I think, if I don't forget, I think this is the formula. Where is this? Yeah, n minus f plus 2p plus 1 divided by stride, basically. Stride is also there. So now we are there, like, so we have a filter. Basically, filter is basically a bit matrix that will be hyperparameter. Basically, at the time of training, it will be reinitialized every time if you do a back propagation. So this is basically our bit matrix, and we have to multiply this by this value. And basically, we at the first time we will put this value into our first box and then calculate a bit matrix according. So by putting this value, we have, for this basically filter, or we can say that a vertical edge filter. This is a random matrix, basically, or basically a bit matrix. This will be, there is some types we can see that are based on initialization techniques are there to initialize this bit, like normal, he normal is there also. So we have to multiply, firstly put there and then multiply this, and then we will get some output. Again, if your start is one, then we have to take a one step ahead and then again do the same thing until we did not get a out last layer. And the second time, basically, we will now take a step back, like in down, and then again do same calculation, and then we take one step to the right, and then again same calculation, different, and then you will get some output matrix. And this is the output of your first layer, and this output will be input of the second layer, basically. And then we have to apply some, here also we have to apply some pooling layer after filter. After applying the filter, we have to apply Adam optimizers is there. Optimizers, not optimize, activation function, basically we have to apply a activation function. After applying a activation function, like ReLU activation function, and then we have to get apply a pooling layer, basically. So in pooling layer, basically there's three types of pooling: max pooling, min pooling, and average pooling. So basically most of the time we use max pooling and average pooling. Min pooling is not required, because if you apply min pooling, then your good features will be gone out. So max pooling basically take a good features in your image, and average pooling basically take the average of all these filters. So there's the different types of pooling. So the formula to calculate is n minus f plus 1. And the second is padding in CNN. So if you apply a padding, suppose you want to get a same matrix. If you apply a 3 by 3 matrix and you want a same matrix as an input and same matrix as output, then we have to apply a padding in the input layer. So if we apply a padding, the formula will be now for the output layer n minus f plus 2p plus 1. Suppose your input is a 6, And if you apply a filter size of 3, then 2p plus 1. So p is a basically a padding, and we suppose we apply a padding of 1, so it's become a 6 only. Like padding, if you want to calculate, padding is equal to same 1. So if you apply a padding equal to 1, then you will get a same input and same output as a uh, image. If you want to give a same image of a model, and if you want a same output as a image, then we apply a padding equal to 1, so the and the filter size equal to 3 by 3, then so that we can get a same image. But in max pooling, or if you apply a pooling, then your image size will be reduced to half. So how much padding you need to apply? So 7 cross 7, 3 cross 3, 7 cross 7. So basically it depend on our filter size. If we apply different types of filter, then it will be changes. Basically it depend on filter size. Operation of CNN and ANN. Now I think you will know, able to know this. So basically the filter size is a hyperparameter, and padding is also a hyperparameter, but input is fixed at the time of training. Suppose we have passed an image of 255 into 255 into 3, like RGB image, and you want a same image as a output. So we have to apply a padding equal to 1 and filter size equal to 3. Suppose if you apply a filter equal to 5, then our basically padding will be increased. Like pad, if you then you have to apply padding equal to 2, so that we can get a same output as a image. So that's it for in this padding. And there's also a stride is there. So stride means basically step, how much step after like applying all of this bit, how much step you want to go ahead, basically. This is the meaning of stride. And so if you apply stride, then you have to divide this n minus f plus 2p plus 1 by 2, by basically by s stride. Now operation of CNN and ANN. So we know that also basically in ANN, basically x1 w1 x2 w2 is there. So basically the summation of xi wi matrix plus bait with bias, and then I apply a Rayleigh activation function on the z, so then we get a some output. Suppose we have an image of like this, half black and half white, and then we apply this filter size of 3 by 3, then we will get a some output like 1 2 3 4 6 by 6 image, then we will get a 4 by 4 of image, because we apply a 3 by 3 3 cross 3 filter size. So this is the like Rayleigh function, Rayleigh operation. We apply a Rayleigh optimizer, so basically we will get a 0 comma max. So if we apply this, then 0 0 0 0, all of this value become 0. Now CN, convolution layer. So basically we apply a different of filter size also. At the time of training it will be changes, max pooling, and mean pooling. So I already told that we have a different types of pooling layer also. Wait 2 minutes. Now coming to max pooling, min pooling, and mean pooling. So basically most of the time, like 95% we will use max pooling, and mean pooling also sometimes it is required. but min pooling we will not use. Like if you, I think min pooling will give you a bad feature, so that's why we will not take as min pooling. Every time we will take a max or min pooling. So max pooling will give you, suppose in your in your image, if you apply a max pooling, then max features like maximum intensity features or a good features you will get in your image. So that's why we will apply a max pooling layer. So the idea of pooling layer is to get a mm, mm, good feature. So like how to apply? So firstly, give the input image to our ANN or we can CNN model. Then we apply a filter. So suppose if we have image of 255 to 255 and apply a filter of 3 by 3, then your image size will be reduced by 2 pixels. Like you will get a 253 by 253 image, and then apply a max pooling on this, and then apply our activation function. So activation function is basically a redo, which is basically max of 0 comma x, and then we apply a pooling layer basically in deep learning. So the pooling layer basically you reduces your image to a half. Like suppose if you have image of 253 by 253, then your image will be now 253 by 253 divided by 2. Like your size will be now half, and then this image will be passed through your second neurons, or we can say a second layer of your CNN network. That's how this will work, and this will continue until you define your model. So location, like yeah. So the question will be why we have to use CNN and what is the advantage of CNN? Suppose what happen in traditional machine learning algorithm, or we can say a normal machine learning algorithm, you will train your model, so he knows this dog. Uh, but if the suppose a second dog will came and the size will be different of this dog, then this will not able to recognize in NLPF. You are doing. But in CNN, suppose location intervariant means a dog is present here. Suppose in your, suppose we have an image in dog is present in the left corner, and the second image will have a dog present in the left corner. So by applying a filter, basically this will take features of that filter. Like we have a different layers of filters. This filter will remember this but basically if we have a feature like this are dog related features, then a filter of any filter will, there are different types of filter. One filter will know that this is a dog, and another filter will know this is a cat. So that's how this will work basically. So if your location is different, or suppose your dog size is basically in first image 25% of your image, and in second image basically it's 85%, then it is also able to recognize this because it applying a filter or for different size. So that's how it is able to remember this all of this location invariant. If you have location invariant problem or a different size problem, this can able to solve it basically. So that's why it is popular. Fully connected layers in CNN. Let's how the CNN model will looks like. Suppose if you have an image of input of 28 by 28 by 1, basically a black and white image, then this image will be passed through your CNN first layer. We can say a convolution first layer. And we apply a kernel size, or we can say a filter size of 5 by 5 and valid padding. If you apply a valid padding, then your output will be also a same. uh, Belt padding, padding means basically belt padding you have applied, so the padding will be 0 basically in this case. So now your size will reduces to 28 by 28 to 24 by 24. Basically be applying so n minus f plus 1, so n is 28 minus f filter size plus 1, so it's will be 24 by 24. And cross n1. N1 means like how many filters you have applied. So at the time of training, we have to say that we have to apply this number of filters, and like this is the filter size. So every filter will remember different things in the image. Now we have to apply a max pooling. Of max pooling also we have to say that like how what is the size of our max pooling. If you apply a 2 by 2 max pooling, then your image size will be half, like 12 by 12. Then again apply a in the CNN2, like convolution layer 2, we have to apply again a filter. Then your image again, if you have 12 by 12, then it will be 8 by 8, like using a n minus a plus 1 formula. And then again our max pooling, so this will be your 4 by 4 matrix by 4 by 4, and the number of channels you have defined. Now we have to apply a flatten layer, and after the flatten layer we have to apply a ANN architecture, basically fully connected layer, and the relay activation function we have to apply here. In ANN basically we have to apply a relay activation function here. The relay activation function is basically replaced by max pooling or min pooling or average pooling. And here the ANN is introduced. So inside ANN we have to apply activation function, and after the for output we have to apply a again a fully connected neural network, and here we have to apply a softmax activation function. Basically this is a classification problem, so we have to apply softmax activation function. Loss function also optimizers. Basically we have to for this, basically categorical cross entropy we have to use as a loss function. That's how it is will work. So suppose if you have an input image of 20 by 28 cross 1, then it will be flattened in a like in one layer, something like that. 1 2 3 4, and all of these things will be passed inside a neural network. So that's how you can say that is also a seen in complete example. Like this is your input image, and legs of zebra will be remembered by this layer and pooling layer, something like that. Every picture will remember something, some different things, like convolution and relay activation function, convolution and relay activation function will be applied. And then we have to flatten, we will get a pooling layer. Firstly we have to apply a filter, and then filter apply a relay activation, and then after apply a relay activation function we have to apply a max pooling, and then max pooling again same thing will be happen until we will not get a flatten layer, or it's depend on your choices how many CNN layers you want to do. And then if we have to apply a flatten layer, after flatten layer we have to apply a ANN model, and then ANN model will give some output. That's how it will work. So that's it for CNN. I think you will able to understand it. So in basically CNN, only 3 4 things you have to remember, like what is filter, what is max pooling, min pooling, and how this will work. So if you apply pass an image as an input like 28 by 28, then we apply a filter, and filter will give different side. It's basically a hyperparameter. It depend on you how much filter size you have to apply. Suppose you apply a filter size of 5 by 5, and suppose you want to get a same dimension of image, then we have to apply a padding according to this. Basically a filter size, so the formula is n minus f plus 2p plus 1 divided by s, or stride is also there, but most of the time we will take stride as a 1 normally, like default value, so that we can get a good accuracy. So that's how it will work. And after that we apply a ReLU activation function on the convolution layer, and then apply a max pooling. So the our max pooling is also a different size. If you apply a 2 by 2, it's a default value, then you get a half of the images size. Like if you apply a 28 by 28, then your images now will be 14 cross 14. That's it for CNN. I think you are able to understand it. That is for deep learning, guys. I have covered all of these deep learning related things. I think you are able to understand it. It's good if you are able to understand it. Let's meet in the NLP. I will start the NLP from tomorrow. Let's see how this bill goes. I am working very hard to explain you all of these things. Basically, I am explaining in a very small period of time, but it will take many time if I will go to with basics or explain you. So let's guys meet tomorrow and start our NLP task, or we say a playlist. थैंक यू गाइस, जय हिंद, जय भारत। मिलते हैं नेक्स्ट लेक्चर में।